Hello, in this lesson, I want you to graph and analyze cube root functions. The vocabulary you're coming across is cube root function and inflection point. So if we look at a cube root function, notice it looks kind of similar to a square root function, except it's defined because you can take the cube root of a negative, so it's defined for negative numbers. So what happens, our domain, I can put any number in. I can take the cube root of any number, which means if I can take the cube root of any number, I can have any answer. So my domain and range are always all real numbers. Notice it crosses the x-axis at 0 and the y-axis at 0. It's symmetric across the origin. It has point symmetry. That's your point of inflection. And as x approaches positive infinity, f of x approaches positive infinity. As x approaches negative infinity, f of x approaches negative infinity. It doesn't have any relative maximum or minimum. So now, when we talk about, on example 1, to identify the key features, that's what I'm looking at here. You're not going to solve any problems. You're just going to describe it. So we'll start here with our domain. Our domain is going to be all real numbers, because you can put any number in for x and get an answer. Your range is all real numbers. Notice there's been a transformation going on here. My x-intercept got moved to the right too, didn't it? So the x-intercept is at 2. My y-intercept, notice it's a decimal. So what happens is I'm going to take 0, replace that with x. So 0 minus 2 is negative 2. I take the cube root of negative 2, and I take the opposite of that. So in other words, my y-intercept is the cube root of 2. Or the opposite of the cube root of negative 2 if you want. There is no symmetry, or there's point symmetry, I should say, but no line symmetry. So there's point symmetry around 2, 0. And then my end behavior, because there has been a reflection, it's backwards, isn't it? As x approaches positive infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches positive infinity. As x get really, really big. Okay, we don't have any relatives maximum or minimum, and our inflection point is 2, 0. And just like in the last lesson, and every transformation we've done so far, if you go inside the cube root and you subtract it, that's going to be a horizontal translation. If you add something to your function, that's a vertical translation. If you multiply your something, that's going to be a dilation. If what you multiply is less than 0, you're going to flip it over the x-axis. And if it's bigger than 1, it'll be a stretch. And if it's less than 1, it'll be a compression. Between 0 and 1, I should say.